Hello everyone, myself Dr. Rajesh Prasad, working as professor in CSE department at AKGC Ghaziabad. So I'm going to discuss push-down automata in the context of the theory of automata and formal languages. So this is the outline of push-down automata. Generally, if you understand, this push-down automata is of two categories. One is non-deterministic push-down automata and second is deterministic push-down automata. Unlike in finite automata, by default finite automata is deterministic in nature. But in the context of push-down automata, by default we are just considering non-deterministic push-down automata. Deterministic push-down automata is very restricted version of the push-down automata, NPDA, right? So, and unlike finite automata, NFA and DFA, they used to be equivalent. But here, NPDA and DPDA, they are not equivalent. There is differences between NPDA and DPDA. That means you cannot convert every NPDA into equivalent DPDA, right? So let's see this and the push down automata, and we know that every CFG and push down automata, they are equivalent. They can be every CFG can be converted into PDA and PDA can also be converted into CFG. So question is that let's have little bit introduction of the push down automata. Why we need push down automata? We know that regular languages like finite automata, they are they used to fail in certain class of languages like C. If you want to design a finite automata for this, you cannot design because this finite automata fails to recognize A and B and there are some other class of languages. Why it is finite automata fails to recognize AN and BN? If you understand it, there is a not only language, there is a counting also. A and B number should be the same. And we know that this is not a regular grammar, a regular language. And it's a context-free language. We know that it is ASB or AB. This is the context-free language, CFG of the grammar, like CFG of the language. So finite automata, this has the tape, we call it gamma, and input tape, and this is finite control Q, and this is this we call it sigma, and this is known as gamma. We call it stack symbols, right? So this is storing direction and removing direction. So instead of only having finite control and input tape, we used to have a push down stack also, and this push down stack is actually counting. It's used for counting purpose and storing purpose. So many purposes this push down auto stack has, right? Yeah. So if you understand it, this is the model. Like finite automata is the PDA is 7 tuple, right? And this is Q, sigma, gamma, delta, Q0 and Z0 F, right? Yes, this is 7 tuple. Q is like finite set of non-empty set of state. Sigma is input symbol. And gamma is set of stack symbol. Delta is a transition function. Q0 is starting state. From here you are starting. Z0 is bottom of stack. This is bottom of stack. F is set of final state. Remember, PDA can accept the language even without going to the final state. It can accept the language when it enters into the, it can remove the stack. There is no item on the stack, still it can accept. So if you go here, so delta is the main target here. This is the read write head, right? So delta is very important over here. So delta, looking at Q, you are in a present state, right? Looking at sigma, remember this is by default, it is like a non-deterministic in nature. So here it will check the sigma plus it will check the lambda also, right? It will check the epsilon also. Q cross sigma union lambda cross gamma, okay, 2 cross gamma 2 power set of Q cross gamma star. Okay, yes. Why? It is non-deterministic. This state will remain the same, and stack symbol will be pushed or pop, right? So that's why it can be like a gamma star. Very important. See, so yes. Let's have little bit utilization of this. Suppose you are under designing a PDA for A and B. Okay, how to design PDA? There are many ways to design the PDA. You can go and design the CFG, and then CFG can be converted into PDA, or just go and construct without going to the CFG. For example, suppose take a particular instance. Suppose we are taking triple A and we are taking triple B. Okay. So, this finite automata, what it is actually doing, if you are in a Q0 and checking at small a and bottom of stack it Z0, what will happen? What will happen? It will push the stack, right? So, initially Z0 was here. If you are at a state Q0 and looking at a small a, it will keep like pushing. Okay, there is no change of state. Still you remain in Q0. Go to this small a again, and now capital A is on top of stack. Okay, so this will still like be pushing on A. Still like again it is pushing on A. Okay, yes. Okay. Now Q0B, now you are changing the input. So of course, you have entered 3A. So now you are in changing the input. So it's better to enter into the new state and delete it, right? So now you are in Q1, okay? Now you are in Q1 and this guy is deleted, okay? This guy is deleted. Now Q1B and capital A, again it is deleted. Again Q1B capital A, again it is deleted. So what you actually you are going to get, this answer, right? So Q1 and Q1, now it exhausted, Q1 then it exhausted, and lambda, and this is Z0 on top. Okay, so it will decide to do 3 actions. Okay, class. Once you are in Q1, input is lambdas, it can remove the stack, to free the stack, empty the stack, or it can do this one, it can enter the final state, right, and let it remain the same thing, or this can go into both the things. It can go to final state, and it can empty the stack also. Okay, so this can empty the stack also. So these are the possibility of the push down automata, right? Yeah. So looking at this, you can design the delta also for, let's say, A and B. And okay, so how to design delta 1? Look at here, you are in Q0. Looking at small a, and Z0 is on top. As you know that this is by nature, it is non-deterministic. It will remain Q0, and in place of A, you are pushing capital A. So now your stack become AZ0. Remember, Z0 remain as it is. In place of A, you can push capital A, or it sometimes some books they are just like pushing small a also. There is no problem, right? So now delta Q0 is small a is on the input side, and now capital A is on top, right? So this is on top of the stack. What you will get, Q0 remain here, and this you are replacing A and then capital A. Okay, yes. Then third one, Q0 is small a, and now after this, and small b, you are done with small a, and capital A is on top. So you enter into Q1 state and remove this completely. This is the third transitions. Okay, transition will be delta Q1 and then you have B over here, capital A is here, still you can go to Q1 and keep removing, right? So this is the fourth one, and then Q1, and still you are here, and there is no input, right? You are done with the input, and Z0 is on top. So you have three options. You can go to Q1 and it be removed, or you have another option, and you can enter into Q final, take another states, and it can be remaining 0, Z0, or it can go to Q final and then enter into the final, empty the stack. So this is one of the way to convert to get design of PDA, right? Another important thing is that CFG to PDA. How to design? How to design, like convert CFG to PDA? Instantaneous description, you know it already. So I'm focusing on CFG to PDA. This is important. Most of the time that it is coming, that how to design a push-down automata from the given context-free grammar. Let's have an example, like say, let us have the same question, an, bn, right? Yes, n greater than or equal to 1. So if you are converting a particular context-free grammar to PDA, design its CFG first, right? So we know that its CFG is S goes to ASB or AB. This is number 1, this is number 2, right? Yes, two productions we have. So this CFG to PDA, there are two rules very common, right? Rule number 1 is saying that for each production, okay, for each production of the farm, CFG to PDA, A goes to alpha. You remember we have CFG, you see, we have CFG, right? CFG means V sigma SP. We have this one, and you are going to get PDA. PDA is means M Q sigma delta Q0 Z0. Here this PDA final state is going to be empty. In fact, CFG to PDA it is accepting language by empty store. Remember, it is accepting language by empty store, right? And later on you can prove that empty store to final and final state to empty, both are equivalent. So now you know you have CFG, you are going to PDA. So this guy you are going to get Q. Yes. So you know you are going to get Q. So generally Q is like what? You know, you see, you are going to get Q. That is number 1. And number 2, you are going to get sigma. All these tuples you are going to get actually. Okay. Yes. So what will be the Q? Q will be in fact all this letter of capital V. All this will be capital V, including starting symbol. Remember, starting symbol is also part of Q. Sigma remain as it is. This is the destination you have to get, right? It is like, and Q0 is nothing but it is starting symbol. I'm skipping delta for time being. Z0 is also start of the symbol, okay, and Q sigma gamma, there is like gamma which is left, right? And gamma is nothing but gamma is V union sigma. You know, non-terminal and terminal both are element of the gamma. Z0 is starting, we are pushing the bottom of stack here, and like we are done with 1, 2, 3, 4, 5, right? And final state is 5. Delta is for this rule. Delta is designed by this rule. For each production of the farm, A goes to alpha. We are including delta, Q comma, lambda comma, capital A is on top of stack, right? Capital A is on top of stack. What you are going to get? it will take only one state, and this Q for A it is replacing alpha. This is rule number 1. Delta is this number, rule number 1. Rule number 2 is like for each small letter AB belong to sigma. For each small letter, what you are going to do, Q comma same A and A, this is going to pop the stack. Remember, we are having only one state. This is only two rules are there for delta, right? For A goes to alpha, Q, lambda, we assume that there is no input and A is on top of stack Q, and A is going to be replaced by alpha. Similarly, Q comma small a, this is going to be empty the stack, right? So let's have one example of A and B and first. Okay, yeah. So how to design the for this? Okay, how to design the PDA? This is number 1. This we can say that this is alpha. This is alpha. Okay, so from rule number 1, we can say that delta Q comma is like lambda input, there is no input. Remember, this CFG to PDA by default is non-deterministic in nature. So it is not like going to be deterministic. Q comma lambda comma S. What will happen? It is going to be Q comma S is replaced by ASB. This is number 1. Similarly, delta Q comma lambda comma capital S, this is replaced by Q comma AB. Okay, yes. This is number 2. Number 2, right? Yes. You can combine both in together, and since the grammar is having two terminal, Q comma same A is going to be Q comma lambda. This is number 3. And similarly, delta Q comma B, this is also going to be replaced by Q comma lambda. So these are the transition function for the CFG. Very simple, and yeah, it is very simple construction. Okay. Similarly, let's say this is very important question. Like most of the time, this is coming in AKTU examination. Constructive PDA equivalent to this CFG. Okay, and this is CFG. S goes to 0 BB. Okay, and then B goes to 0 S or 1 S or 0. And then they are saying test this is in language or not. So if you understand it very well, this is one grammar 3. So what will by rule 1 delta Q comma lambda, remember by nature it is non-deterministic. Okay, and then S is on top of the stack. Okay, so this will be Q. S is replacing by 0 BB. This is replaced by 0 BB. Number 1. Okay, this is number 1. Number 2, delta Q comma lambda comma S, sorry, not S, B. This is B is going to be replaced by Q comma B is replaced by 0 S. Okay. Similarly, if you go by this delta Q comma lambda comma B, this is replaced by Q comma 1 S. Okay. Yeah. Next is delta Q comma lambda comma capital B, it is going to be replaced by Q comma 0. That is next. Okay. Then next one is delta Q comma input is 0 and 1. Same. It is going to be like Q comma lambda. Same you just pop, right? And then delta Q comma 1. Okay. And it is also going to pop the stack. So this is the delta for this. Very simple construction. Okay. Now next question is that whether this is part of the language or not. This is sometimes is very demanding. So how, just start with its instantaneous description. How to check it? Start with Q. Okay. And put 0, 1, 0 to the power 4 here. and starting symbol will be here. Okay, yeah. So now check Q0 capital S. So Q is not there, but remember, if you don't get Q0 capital S, assume that lambda is here. Okay, Q lambda capital S. Okay, so Q lambda capital S, you have only one option here. Okay, Q lambda S, you have only one option. So this will remain Q, and 0 1 0 to the power 4. S will be replaced by 0 BB. That is it. Simple. This is the one which we are using. Now you know Q00. Q00, it is deleted. So this finished now. So you will get Q10 to the power 4 and BB. Again, you will not get Q1B. You will not get Q1B. So anywhere if you are not getting, take Q lambda B. Q lambda B, you have three options. This option, and this option. So you need to decide. Definitely, if you take Q lambda B, this option is not going to work because we need one here. We need one here so that it can be deleted, right? So Q lambda 1 is not, this is not going to work. Okay. And of course, this is going to work. Okay. So what will be happening here? Q and 10 to the power 4, and B is going to be replaced by 1 comma S, and then this will be B is replaced by 1 S, then 1 S B. Same, look at here, it will cancel out. Q0 to the power 4 and then SB. Okay, again you will see, you will not get Q0S, you will get Q lambda S. So Q lambda S, only this option is there. Okay, so Q0 to the power 4 S is replaced by 0 BB, and then B is already there as previously. So now you see 0 1 0 is out from here. So you will get Q, then 000 and then triple B. Okay, yes. Okay, so what you will get, then Q0B. Again, Q0B is not defined. So Q lambda 0 000 then triple B. Okay, yeah, Q lambda B, you are going to use this option. Okay, so Q then 0 and then 0 BB. Okay, this will cancel out. So you will get Q then 0 and then B. Similarly, Q0B is not defined, but Q lambda B is defined. If we follow this instruction, you will get that this is Q lambda lambda. So now stack is empty. That means this language is accepted by the pushdown automata. So this is very simple construction, very simple construction. Okay. So you can also take another example like CWCWR, right? Yes. So if you want to get WCWR, design its grammar. S goes to C, or S goes to, let's say, ASA or BSB. Okay. So this is grammar for this WWR, where W belong to AB star, right? So this can be like, you can design the CFG by using this method rather than going by another method. So yes, so this is the complete references. I'm having lack of time, so cannot be like finishing PDA to CFG, but we'll do in the next lecture. Thank you.